Hello everyone, this is Shruti Parashar and you all are welcome to my channel Shruti's World. So in the previous video we had basically discussed about the Newton's second law of motion, weightlessness, weight and mass. That was the video for Dynamics part 3. You'll find it in my channel, so you can just search for it. And now in this video, we'll be taking this topic of dynamics a bit further and we'll be discussing about Newton's third law of motion. So let's get started. So Newton's third law of motion states that for every action, there is an equal and opposite reaction. So this is a one sentence law of motion, which is very simple to understand. And it is indeed interesting. So, for example, we hit a table with our palm with force. We experience pain because the table exerts an equal force on the palm in the opposite direction. So if this is the table and we exert the pressure with our palm towards the right hand side, then the table is going to exert the pressure on the opposite side, that is towards the left hand side. Hence the action that is our palm hitting the table, and the reaction is the table hitting the palm. So the force that will be applied in both the cases will be equal, because every action has an equal and opposite reaction. Now let us look at the second example. When a person swims, he pushes the water backwards. So a person needs to go forward. Right there. So he is pushing the water backwards, and the water in turn pushes the person with equal force. So the water is going to push the person with equal force and he's going to move forward. So the person is pushing the water backwards and he's going forward. So this person is pushing the water and the water is pushing it back with equal force in the forward direction. So every action has an equal and opposite reaction. So the force with which the person is pushing the water has to be greater if the person has to reach his desired point in that particular water body or whatever it is, the pool, faster. This was Newton's third law of motion. Now we talk about the principle of conservation of mass. So, for example, measure the mass of a block of ice. Allow the ice to melt completely, collect the water, and then measure the mass of the water. You'll notice that the mass of the ice cube and the mass of the water, the melted ice cube, is same. So it is found that both of the masses are same, hence there is no gain or loss in the mass. So we can say that although we had heated the substance and it changed its state of matter, the mass was same. So with this experiment we can illustrate that mass can neither be created nor can it be destroyed. This principle is called the law of conservation of mass. Now that we've talked about conservation of mass and the third law of motion, we come to another topic, that is work. So in general, if we stand in the sun for 5 hours and we hold say a weight on our head, for example, the coolies in the railway station, if they put some boxes on their heads and they stand in the sun for 4 to 5 hours, in general we can say that yes, we are doing work, because in general work represents any physical or mental activity. So in general, work does not need to be done physically. If we are applying our brain, we can say that yes, we are doing some work. But in physics, work has a precise meaning. That means that work is said to be done only when a net force acts on the body and the body undergoes displacement. That means that if we stand in the sun for 4 to 5 hours with with two boxes of or two cartons in our head, according to physics, we are doing no work. We are completely wasting time. So yeah, you may think that yes, we can say that physics is cruel in such situations, but it is what it is. You can't help it. So basically, if you start walking with that load on your head, and even if you walk 2 meters or 3 meters, then we say that yes, physics is going to say that yes, you've done some work, good job. So let's take another example. For example, you are pushing the wall for half an hour with all your force and you're not able to move it. Of course, you'll not be able to move it. So if you're not able to move it, then there is no work done. So for work to be done, the conditions are very precise. There has to be a force acting upon it, and there has to be a displacement. If there is a force acting upon some object but there is no displacement, that means it is not moving, then we do not say that the work is done. We say work is not done. But if we are applying some sort of force and the displacement is happening, then we say that yes, work is done. In this case, when we are pushing the wall, although we are applying force, we are using our strength, but there is no displacement, hence there is no work done, so there is no use of pushing the wall. So work basically is force into displacement. So this S right here is not for speed because we are displaying it as a vector quantity because it has an arrow on the top. So this is displacement. And this F is force. It is again a vector quantity. We have displayed this one with an arrow as well. So basically, if work is force multiplied by displacement, then the unit of work is unit of force multiplied by the unit of displacement. So the SI unit of work is joule or Newton meter. Although work is force into displacement and both of them are vector quantities, work done is a scalar quantity. That means that we do not bring into account in which direction the work is being done. It is just that yes, it is some magnitude, it is some joule, it is some value that yes, work is being done. That is all. We do not need to specify in which direction the work is being done. I hope you guys enjoyed the video. Thank you for watching. In the upcoming video, we will be talking about energy and center of gravity. Do like, share and subscribe. Do log on to www.ygenlearners.com. This is my website. You will find blogs written by me. For more knowledge, keep in touch. Thank you.